Welcome back. This is page 39. What we're doing for this one is I am going to give the cart a push. It's going to go up the ramp, slow down, get to the top, and then I'm going to let it roll back down again. So it's going to come back down again, and it says catch the cart just before it reaches the motion detector. So I'll stop it just before here. So this time it's an up and down the ramp. So I would like you to, once again, make sure you have a go before you look at how I've done it. But pause the video and attempt them. No, actually, stop. I'm going to show you what it looks like. So I've got my trusty banana. Push it and let it roll down. Okay. Right, so now you can pause the video and attempt the motion map. Okay, so the questions are always answer the questions while it's coasting, so after I pushed it. So I've pushed it, it's got going with plenty of speed, and away she goes. And it slows down. Velocity, 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 much smaller, velocity, it gets to a point it slows down, and then it starts coming back the other way. I've got to fit these in, and it starts off slow, and it gets further and further apart. Velocity, 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 velocity. This is going to be tough to draw my acceleration arrows. I might draw my acceleration arrows above on the way and below on the way back. So it looks like it's slowing down. So that would mean I can't have an acceleration arrow going this way between here and here, because that would mean it'd be speeding up. So my acceleration arrow is this way. Again, my acceleration arrow is this way. Acceleration arrow is this way. On the way back down, between here and here, it's speeding up. So I need my acceleration arrow to go this way still. Going in the same direction. And I'm going to draw my signs to show that it's uniform acceleration. So even on the way up and the way down, even though the velocity changes direction, my acceleration is in the same direction. Even though on the way up I'm slowing down, and on the way down I'm speeding up, acceleration always points back towards the origin. So C, is the velocity positive or negative? Well, it's both. Does the direction of the velocity change? Yes, it definitely does. Is the acceleration positive or negative? Well, the acceleration the whole time points away from the positive. It's negative the whole time. Does the direction of the acceleration change? No, it does not. Once more, these are going to be really helpful when you think through the graphs. So the acceleration doesn't change, it's negative the whole time. Big hint. The velocity changes, it starts off as positive and ends up first as positive and second as negative. That's going to help you as well. So just like last time and the time before that, it's really important that you attempt these graphs. Doesn't matter if you're right or wrong, and then I will do the experiment and we'll see what we get. Right, so hopefully you attempted your graphs. If you haven't, pause the video and do them. Let's have a look at the experiment. Don't look at these graphs, this is from last time. I've got it set up on the 0 position. Yep, and I've set the trigger up so it's ready to go, and I push start, and now it's all about how good's my push going to be. Ready, go. Oh, it's pretty good. Nice, beautiful. Look at that. So here's my position time graph. It starts off close to 0, and it starts off quite steep, ends up flattening off around the top. So, velocity is nearly 0 around there, and then increases in the negative direction. My velocity graph starts off quite high positive, ends up going through 0 at some point, and then out the other side, when it's going down again, it becomes negative. My acceleration the whole time was just like my motion map, negative the whole time. That's really good data. I'm really pleased with myself there. Can I just point out something? When it reaches the top here, it's flat, so you know it's 0 velocity, and you can see it crossing the axis here at 0 velocity. What's the acceleration as it crosses the axis? It's still negative. Just something to think about. All right, so let's draw those back in. I want to go to this one. Right, so let's go red. The position time graph, what did that look like again? Oh yeah, that's right. It was like a hill. Started off steep, going fast, was 0 around the top, and then became negative on the way down. The velocity started off positive. In the middle it was 0, and then it was negative. I wish I could do rulers on this, but I can't. It's meant to be a straight line. My acceleration was negative the whole time. Describe how the slope of the position time graph changes. It starts positive and steep. The slope becomes 0 for a time, and then it becomes negative. Describe the slope of the velocity time graph. So I'm not describing the velocity time graph, I'm describing the slope. The slope is constant, the same slope, and it's and the slope is a negative slope, isn't it? Because it's a positive slope would look like this, and it's definitely a negative slope. All right, great, thank you.